We want to consider now what happens for large t. Now for large t, the t squared k becomes dominant. This term takes precedence over everything else. We are going around a circle, and we're moving up at the same time. We're moving up faster and faster, and there's no limit to how fast we can move upwards. What's that going to do? If we're moving around a circle, but we're moving a large distance upward, our path is going to be almost straight. So the path becomes almost straight, leaving letters out here, straight, pretend the eye's in there, and curvature of a straight line, well, the straighter the line gets, the greater the radius of the circle that matches that part of the curve, so that the radius of curvature is going to become infinite, and the curvature approaches 1 over radius of curvature, and that's going to be 0. Radius of curvature is going to approach infinity, and our curvature is going to approach 0. Let's see if that's borne out by our expression. Now, the denominator is the thing that's going to trump everything. Okay? If we take everything in our numerator, we have a t squared here multiplied by cosine of t, and a t squared here multiplied by the sine of t. We have t terms. Without going into great algebraic detail, you should understand this from first year calculus, the t squared terms are simply going to dominate everything else. So that what we're going to have in the numerator is something that's proportional to t squared. The numerator is proportional to t squared. The magnitude of the numerator is proportional to t squared. The denominator is going to be proportional to the square of t squared. So the denominator is going to be the square root of pi squared a squared plus 4t squared to the 4th, which is proportional to t to the 4th. If you ignore everything else in here and don't even worry about the 4, as t gets very large, this square root, well, it's going to be close to 2t, the square root of 4t squared. So it's going to be proportional. This part is going to be proportional to t, and when we raise that to the 4th power, it's proportional to the 4th power. So we can simply say, with a little hand waving, as t goes to infinity, the magnitude of the curvature, and of course the curvature is a positive quantity, so I didn't really need the absolute value signs, but the magnitude of the curvature is proportional to t squared over t to the 4th, which is 1 over t squared, and that approaches 0. So that, as expected, our path becomes almost straight, our curvature approaches 0, and if we analyze the t's here and consider the limit of this expression as t approaches infinity, we're going to find that it's dominated by the 1 over t squared and therefore approaches 0 as expected. Any error I might have made in getting this expression, and as seen in the previous clip, I believe there is some sort of an error. But any error I made there is probably not going to have been reproduced enough times to get rid of the t-squareds here and the t-squareds here, and to raise these t's to any powers greater than the second, so that this denominator is still going to dominate as t approaches infinity. And the error I made affects the result for small values of t, but isn't going to really have any large effect as t approaches infinity.